Okay, welcome everyone. Today we're diving into K0s. And you might be thinking, do we really need another Kubernetes distribution? Well, that's exactly the question we'll answer in this talk. We'll explore how K0s is redefining lightweight Kubernetes. We'll start with the fundamentals, comparing leading lightweight distributions, and culminate with a practical demonstration of its powerful capabilities. Before we dive into the technical details, let me quickly introduce myself. My name is Jing Guo, and I'm a technical support engineer at Mirantis, where I work with the cloud-native technologies, Kubernetes, and OpenStack deployments daily. I'm also an active volunteer with the cloud-native Taiwan user group, and recently shared insight at KubeCon North America in 2023. So here's all the key highlights that we'll talk about today. We'll start with understanding what makes Kubernetes lightweight. Then we'll talk about k0s with a short and simple introduction. Next, we'll compare the three distribution that you might heard of, looking at what k0s stands out among these three. At last, we'll give an introduction to k0s Motron and a hands-on look on how it works with Cluster API to deploy a Kubernetes deployment. By the end of this session, you understand why k0s isn't just another distribution. It's a practical solution to real Kubernetes adoption challenges. So this is an architecture graph of Kubernetes. So we're going to start by understanding why we're even talking about lightweight distribution. So stock Kubernetes is powerful, comes with some challenges. First, the resource requirements for it. It basically needs significant CPU and memory to actually run the control plane. It's designed for enterprise scale deployment, scaling into multi-thousand nodes. And it's often too heavy for local development or edge computing. For developers, this creates some real pain points. Things such as slow startup times affecting your development cycles, your CI/CD pipelines become resource intensive as you need to run a full scale of Kubernetes cluster. A more complex setup process with multiple components, such as shown in this graph. You have etcd, you have a Kube API server, the scheduler, the controller manager, and many more. So these challenges are exactly why these lightweight distributions have gained so much attention. They address these pain points while maintaining the Kubernetes compatibility. You're probably familiar with the big three for lightweight Kubernetes. First is K3s by Rancher, k0s by Mirantis, and microkubernetes by Canonical. Each of these distributions takes a unique approach to solving the problems we just discussed, and they all have their sweet spots for different use cases. In the next few minutes, we'll compare these distributions, understanding their key differences, and help you decide which one might be right for your needs. Let's break down how lightweight distribution achieve the efficiency compared to stock Kubernetes. Here are some key design differences. First, it's simplified packaging. It's basically a single binary or a stack package for deployments. While it replaces multiple container-based processes for some really good benefits, such as smaller footprints, quick and one-step installation, and a reduced complexity for installation and management. While it's also used some alternative storage solution other than etcd, which is lighter and more resource efficient, such as SQLite or DQLite. They are enabled through a project called Kind, which acts as a database abstraction layer, which maintains the compatibility with Kubernetes, but significantly reduce the resource usage. Last but not least, some of the optimized components and lightweight default options, such as using Flannel or kuberouter for networking, selective feature enablement, while the core features are maintained so that you can use Kubernetes as normal, but optional components are disabled by default to make the control plane more lightweight. All these optimizations give you the power of Kubernetes without the heavyweight infrastructure requirements for the stock one. So here are some ideal use cases for these distributions. First, is edge deployments, embedded devices, or IoT. They are perfect. These deployments are perfect for resource-constrained hardware to basically enable you to run Kubernetes on these devices with lower CPU power and less RAM, while maintains the core functionality of Kubernetes with a minimal footprint. Next is CI or CD environments. The faster or easier deployment of this distribution makes your CI/CD environment faster and simplify the configuration that you need to run these environments. This makes your test cycles and builds faster, which will be quickly accelerates your development cycle. Next is developments and learning. These small deployments are ideal for home labs, great for stage environments, and perfect for people who just start learning Kubernetes. Those minimum resource overhead basically let you run a full-scale Kubernetes environments on your development machine. But what about production or larger deployments? Yes, these distributions can handle large deployments. You just need some proper configuration tuning, enabling the stuff that's or features you need for these larger deployments, using a better or backend for storage, and consider your specific requirements such as your workload types, your high availability needs, or resource constraints. The key to choosing the right distribution is basically for your specific use case. And let's quickly compare these three leading lightweight distributions. Here are some common grounds which they all support major operating system platform, Linux, Windows, some are experimental. They support basically all the CPU architecture that you're familiar with, x86, ARM. They have multiple deployment methods. K0s and K3s use a binary approach, while micro-Kubernetes use snap packages, and they are all production already. Some of the key difference, such as K0s, you have FIPS 114-2 accreditation. So if you need, if you're working as a government, will need these kind of accreditation, K0s is what you can choose. It has enterprise support options while using a single binary approach for deployment. While K3s is known for edge computing, and it's embedded in the Rancher or SUSE ecosystem. While micro-Kubernetes use snap-based deployments and integrate with the Ubuntu ecosystem. And now let's focus on K0s first and explore why what makes it unique. So what makes it special? First, it's used a single binary philosophy. So everything is packed in a static binary, which includes all essential Kubernetes components. You can see on the right, the graph, it includes things such as the API server, the kubelet, the scheduler, the control manager, even the container runtimes that you need to run a Kubernetes. This enables it to use only minimal dependency. You need bare minimum OS requirements to run containers to be able to run K0s. And while you don't need any container runtime pre-installed, as it's already packed in a binary, and no additional package are required. So this creates a very simple deployment. So to deploy a single K0s zone, you only need a free line of bash. So first to download the K0s, second to install the controller, and third to start it. So this design philosophy makes K0s particularly appealing for those who are seeking simplicity without sacrificing the functionality of Kubernetes. There is actually another tool called K0s Control, which is your management companion for K0s. So what it is, it's basically a CLI tool for multi-node cluster management. It's used infrastructure as a code approach using a single YAML file for configuration and handles the complete cluster lifecycle management. So it's utilized K0s for deployments and run the Kubernetes cluster. Well, its key feature includes all the cluster lifecycle operation stuff, such as installing, upgrading, backup and restore, resetting the whole cluster. You can get your kube config, and it also supports air gap installation for networking constrained environment. It's perfect for production deployment. So you need a full-scale, high availability cluster, development environments in some cases, automatic cluster management, and GitOps workflow. So let's shift our attention to K3s, which is another popular lightweight distribution. Similar to K0s, it's follow the philosophy of static compile binary. So it's also used a single binary to keep OS level dependency at minimum, making installation straightforward and resource efficient like K0s. Well, set it apart is its integration with Rancher ecosystem. So if you're already using Rancher for cluster management, K3s cluster can be seamlessly added to your existing deployments, giving you a familiar management interface and a consistent experience across your infrastructure. Well, it doesn't come with an official CLI tool for cluster management. There's actually a third-party one written by the community called K3s Up, which shows the strength of its community support. Well, you might need more research in the community to run it. Now let's move on to our third contender, micro-Kubernetes. What sets this apart is its strong ties to the Canonical ecosystem. So being developed by Canonical themselves, it takes full advantages of their infrastructure. It's distributed through the Snap package management system. You can manage your cluster using the Juju operating framework. So the tight integration with its tooling, the Canonical tooling, makes it a natural choice if you're already working with their ecosystem. Now let's talk about some numbers. I've conducted some hands-on benchmarking of all three distributions, specifically looking into their memory footprints. The results are quite interesting. You can see all three comes in at around 1 gigabyte of memory usage. There's already some pods running on it, but all the same. And there's only a difference of merely 40 to 50 megabytes between them, which is essential within the margin of error for real-world deployments. So this tells us something important. Despite their different approach to being lightweight, all three distributions have achieved a similar level of memory efficiency. This suggests that when choosing these distribution, memory consumption probably shouldn't be your deciding factor. So this brings us to the key question. How do we choose between these three distributions while the performance metrics are so similar? So the basic rule of thumb is simple. Stick with what you know. If you're already familiar with one of these distributions, that experience alone can be more valuable than any minor technical difference. But if you're starting fresh, here's what I found from my personal experience. K0s stands out with its straightforward CLI tool, making installing and managing notable and user-friendly. While K3s has earned its popularity for a good reason, it comes with a lot of out-of-box integration and has the largest community online. And micro-Kubernetes, it's a natural choice if you're already invested in the Ubuntu ecosystem and comfortable with Snap packages. But remember, there's no universally the best option. It's about finding the right fit for your specific context and requirements. Now let's explore something truly innovative that sets K0s apart. There's a project called k0s Motron. This is where K0s single binary approach really shines in a unique way. K0s Motron leveraged K0s streamlined architecture to accomplish something remarkable. It allows you to run a Kubernetes control plane inside your existing Kubernetes cluster. Think about that for a moment. You can run a fully functional Kubernetes control plane, deploy as easily as any other workload in your cluster. So this isn't just a technical feat. It's opened us exciting possibilities for Kubernetes as a service scenarios and multi-tenant environments. Let me break down what it really is. At its core, it's a Kubernetes operator, and a clever one. Its job, managing k0s control planes within any Kubernetes cluster, regardless of which distribution you're running. What makes it elegant is how it works with the Kubernetes native patterns. You simply define your desired control plane using custom resources, and k0s Motron handles all heavy lifting. It automatically creates and manages all the necessary Kubernetes components, the pods, config max, and everything else needed to run your control plane. Here's where it gets interesting. These control planes run completely isolated from your worker nodes in terms of networking. The design opens up a powerful possibility. You can connect worker nodes from literally anywhere or any infrastructure to your cluster control plane. Whether they are in the cloud, on-premise, or at the edge, the location doesn't matter. And for those of you working with Cluster API, there's more good news. k0s Motron is fully integrated as a provider for control plane or bootstrap for Cluster API, making it a natural fit for your automation workflows. So let me walk you through the architecture diagram for it. So what you're seeing is how k0s Motron operates in practice. At its heart, we have a management cluster where k0s Motron runs as a controller. This controller is responsible for creating and managing k0s control plane right inside the management cluster. The really interesting part is what's happened next. This control plane can accept connection from worker nodes located anywhere. Think of it as having your control plane safely tucked away in your management cluster, where worker nodes can be distributed everywhere, whatever your workflow need to be. This brings us to an important question. What makes this architectural approach so valuable? So let's explore the advantages. Before we dive into k0s Motron's advantages, let's look at how clusters are typically deployed using Cluster API or similar management system. In a traditional setup, you start out with a management cluster at the left that orchestrates everything. While this management cluster might be minimal, often just running only control plane components, each workload cluster you create follows a familiar pattern. A dedicated control plane nodes plus dedicated worker nodes. Think about it. For every single workload cluster you spin up, you're provisioning and maintaining both sets of controller nodes and worker nodes. This is a conventional approach we've all grown accustomed to. But as we'll see next, k0s Motron offers an interesting alternative to this pattern. Now here's where k0s Motron changes the game. Instead of provisioning dedicated control plane nodes for each workload cluster, k0s Motron lets you run your control plane directly inside your management cluster as just another workload. Look at the difference. Your workload cluster at right not only need worker nodes. The control planes are efficiently packed into your existing management cluster infrastructure. This is a significant shift from the traditional pattern we just saw. Think about the implications. You're not just saving on infrastructure costs, you're simplifying your overall architecture, reducing the number of nodes you need to maintain, and improve resource utilization. All while maintaining proper isolation and control over the workload cluster. So to showcase the powerful of k0s Motron, we're going to do a demo. In this live demonstration, we'll use Cluster API to deploy a cluster using k0s Motron, where k0s Motron will serve as both our control plane and bootstrap provider, handling the control plane lifecycle and no bootstrapping. While we're using OpenStack for our infrastructure provider, which managing the underlying compute resource for the worker nodes. So this setup will showcase how k0s Motron integrates seamlessly with existing cloud infrastructure while delivering the efficient benefit we just discussed. So let me start to walk you through the process. So we're going to have YAML file for cluster API deployment. So in this YAML file, it's very similar to a simple different provider YAML file for cluster API. In this case, the difference is that in your control plane reference, you're using k0s control plane, k0s Motron control plane for control plane. Well, in the infrastructure side, we're using OpenStack. Well, in the control plane definition, it's basically what's the config for the control plane, such as the version you're running, the load balancer service you're using, some of the control plane flags you're going to use, and the k0s config that you can add it to fit your environment. Well, the infrastructure config is basically the same as when you use other Bootstrap or control plane provider. So basically, it defines all the infrastructure stuff, such as the subnet you're using, the network you're using, the cloud config you're using, and the flavor or the image for the bastion host or other stuff. Well, the machine deployment is the definition for your machine, which is the worker node. While the worker config templates is the arguments and the spec that we'll use for k0s that will be run on the worker node. In this case, we have to enable cloud provider as we're running on OpenStack and setting some extra arguments. Next, we have our worker VM templates, which defines things such as the flavor you're using, the cloud config you're using, the image, and the SSH key if you need to access the worker nodes. So to deploy the cluster, we simply apply the file. Oops, sorry. I got apply. Okay. Yep, it will create all the resource that we defined in it. Okay, so let's switch to Lens, which is a powerful tool. So in this case, we're deploying into the default namespace. In a while, we'll start to see there will be pods spawning on this namespace. It might take a few seconds before we go back to. So we have, I have written a Bootstrap file, which is used for bootstrapping cluster itself, such as installing the CNI and the call controller to make the worker node ready. Well, we'll run this file when the control plane is already ready. Let's move back to C. Okay, you can see currently there's our two pods started spawn. So one is the cluster OpenStack -0, which will be the control plane created by k0s Motron. Well, this with the SCD is the SCD pod used for storage. Well, it might take some time to spawn, so let's move back to the slides and talk about some of the limitation for k0s Motron. So before we jump back to demo and wrapping up all the stuff, we have to be transparent about some of the important consideration when using it. So first, there's a critical dependency to understand. So workload cluster control plane are intrinsically tied to your management cluster. So if your management cluster experiences downtime, all your child cluster will become unavailable as you cannot access the control plane of them. So this makes the reliability of your management cluster even more crucial. Next, high availability also presents a unique challenge. Running etcd inside Kubernetes isn't straightforward due to its dynamic nature, which makes traditional HA setups using multiple etcd nodes very complex. So the current solution involves using Kind, which we mentioned earlier, is an abstraction layer for Kubernetes storage with external databases. So you can use things such as MariaDB, Postgres, or a different database for with HA setup. So this is a trade-off that you'll need to consider. Lastly, since we're not using dedicated control plane nodes, you'll need to be carefully plan where certain pods that traditionally run on controller nodes will be scheduled. There are a lot of Helm charts or upstream repo that default schedule their controller pods of their application on controller nodes. So this might require some rethinking of your workload placement strategy, as there are no controller nodes to run pods. So this limitation won't diminish the value of its proposition, but there are important factors considering when planning your architecture. Let's jump back to, so you can see in demo we have 2 of the pods running. So we can use clusterctl to get the kubeconfig. And let's see if we're using this kubeconfig to get the node. You can see the node is not ready. So let's run the bootstrap file to create the necessary CNIs and cloud providers on the nodes. While using OpenStack commands, we can see here. Cluster API handles the creation of the worker VMs. While we can start to see if the pods that we deploy are spawning. Okay, so you can see Canonical containers and OpenStack Cloud Controller is started to running. So it might take a few seconds to create all the containers. Okay, so let's see if what we see when the nodes right now. Okay, so you can see the node is ready right now. So this is the demo. So you will see we have our control plane running on the existing management cluster with 2 pods, one running the k0s control plane, one running SCD, while the worker node is running on single VM on OpenStack with all the workflows running on them. So in this case, you don't need a dedicated controller node, as all the control plane stuff is running as a pod. So let's wrap up the whole talk. So some key takeaways. So we've seen how K0s isn't just another Kubernetes distribution. It's a thoughtfully designed solution that brings real advantages through its single binary approach. K0s Motron takes this further by enabling us to run control planes as workloads within our management cluster. This means reduce infrastructure costs and simplify management, all while maintaining full Kubernetes compatibility and cluster API integration. While we discussed some limitations, K0s Motron shines in scenarios requiring multi-tenancy, resource efficiency, or cloud-agnostic deployments. So I've included the project links here, so feel free to explore it further. Okay, someone asked about how do you configure the K0s API server flag or kubelet config. So basically, it's similar as using K0s control for deployment. So you will have you can use a YAML file to define all the necessary setup. If you look at the YAML file, cluster API YAML file here, you can see we have K0s config stuff inside the control plane config. So basically, you will have a similar thing. You can written it as a YAML file to define what's the arguments you need for the API server flags or kubelet config. So in this case, so I'm using a custom network provider and disable telemetry. Well, in the worker config tab, you can see more that we have kubelet arguments and cloud provider enable for an API server. It's a similar thing when you're using K0s. you configure it in a YAML file, and you specify to use that YAML file as a config when you install your node. Let's just wrap up this talk. Thank you for listening.